Hello, fam. This is our lesson for percentiles. I want to apologize in advance for all the background noise. I am at home filming this lesson, and so I am hoping that you won't, but I am pretty sure that at some point you will hear the dogs causing all types of ruckus. So if that happens, I apologize. Hopefully it won't happen or last for very long. So percentiles lesson. This is the last lesson in our short unit 2. Unit 2 is based around standard deviation. The only lesson that isn't really based on standard deviation is this percentiles lesson. So we did standard deviation as a measure of spread or variability. And then we talked about z-scores, because z-scores tell you how many standard deviations away from the mean an observation is. Then we went into the normal curve. I guess it would be nice if I showed you guys these pages. So we start with standard deviation. We would prefer a smaller standard deviation because that means that our data is more quote unquote reliable. The process for calculating standard deviation is quite involved. You very rarely have to do this. I've never seen you have to do this on a test. You may have to do this for like 4 data values, but you would never have to do it for more than, I would say, 5 or 6. So standard deviation measures spread. It's the typical distance that the observations are from the mean. That led us into z-scores, which standardizes observations. Now notice standardizes and standard deviation, they share the same word. So standardizing or z-scores tell you how many standard deviations away from the mean an observation is. So it puts your observations in terms of standard deviations. That led us into the normal curve. And the normal curve is related to standard deviations because it has a very specific amount of data within 1, 2, and 3 standard deviations. Now in our next unit, in unit 3, z-scores and the normal distribution are going to come together and help us solve problems on the standard normal curve. So these 2 ideas, we're going to go even further with them in the next unit. So standard deviation, z-scores, normal distribution is still related to standard deviations because the standard deviations tell us how much data is in between them. So then we solved some problems with our standard normal curve. Sorry, not our standard normal curve, our normal curve. We solved some problems with our normal curve. And now we are moving into percentiles. The reason why percentiles is in this unit is because it will become related to our normal curve. So the idea that we see here, we will relate in this lesson to the normal curve, but we are also going to relate it to the standard normal curve, which comes up in our next unit. So hopefully that gives you some idea about where we've been, where we're going, and why these lessons were chosen to be together in this really short unit that I would label standard deviation. Part of the reason that I gave you the baby tabs instead of a big tab is because this doesn't really encompass one idea. Like our last unit was all about exploring data, and our next unit is going to be all about the standard normal curve. But this unit is based off of some ideas that are related to each other that are going to really help us with our next unit coming up. And even if we look back, we can now add in this idea of standard deviation into the describing a distribution that we talked about from the last unit. Okay, so without further ado, let's actually get into this lesson. So, percentiles are a way of measuring position, and we have talked about measuring position before. We have talked about median, Q1, and Q3. So we are familiar with this idea of position because we've used it in the previous unit. Percentiles is another way of measuring position. It allows us to measure the position of a given observation. So let's learn what this is with this dot plot below. The dot plot displays 20 randomly selected Unit 1 exam scores, and these are your real exam scores. I randomly selected 20 of our scores from exam 1. Use your calculator to find the summary statistics. So we're going to go into Stat. I'm going to choose, let me see if that glare is better if I turn this light off. A little bit. Alexa, kitchen on. Is that any better? Nope, fam, we're kind of striking out here. Oh, that's a little better. Okay, so 1, and I'm gonna just put mine in list 6 since I'm already on list 6. So remember to clear out a list. You go up to the top, you hit clear, and then enter. You never hit delete. So we're gonna enter in these values. I have one at 30, 35, 39, 43, 47, 47, 51, 52, 52, 57, just kidding, 58, not 57, 58. So 52, 52, 58, 59, 65, 69, 71, 72, 74, 75, 77, 82, 94. These scores are the not adjusted scores. So these are your actual composite score before I adjusted it up for your letter grade. Okay, to get our summary statistics, we hit Stat, arrow over to Calc. We choose one variable, Stats, and then I already have list 6 entered in. If you didn't, if yours was in list 2, you would hit blue button, the number 2, and then enter through. So mine was 6. I need to go back up and change that to 6. And here are our summary statistics. I'm going to pause really quick and make sure that I got those values right. I did. I should have verified before I went to calculate our statistics. I'm pretty sure that I read the values on the dot plot right. So now we can fill in our information. The mean, or X bar, is 59.6. Oops, sorry, I don't know why I filled that in median. Our standard deviation is SX. So I'm getting 17.05. You could leave it at 17 if you would prefer. Minimum value is 30. Quartile 1, 47. Median is 58.5. Quartile 3 is 73, and the max is 94. Okay, the circled point is Samantha's score. What is it? So we have one circled point up here. That circled point is 77. Samantha scored a 77. Samantha did better than all but blank students in the class. So above Samantha were 2 students, 1, 2. So Samantha did better than all but 2 students in the class. What percent of students earned scores less than or equal to Samantha's? So we're talking about her score and to the left. Well, if only 2 kids are above her, that means that 18 students in the class, or sorry, 18 of these randomly selected students out of 20 randomly selected students scored less than or equal to her. You could also just count them. If you counted up from the yellow dot over, you'd get 18. We plug that into our calculator, and my calculator gives me 0.9. Hopefully it doesn't die soon because I'm in the red battery phase. I always write it as money, so I'm going to write mine as 90. So how many students scored less than or equal to her? 90%. What is Samantha's percentile? Well, turns out her percentile is the 90th percentile. The 90th percentile. So that means that percentile is the percent of data values less than or equal to a given value. The percent of data values less than or equal to a given value. So much like a lot of things in stats, there is a very specific way that they want us to interpret percentile. So when we find a percentile, we would use the sentence frames. The value of X is at the pth percentile. About P percent of the values are less than or equal to X. So we will add context where we can on this second sentence. We will add context. For this problem above, we would say the value of 77 is at the 90th percentile. About 90% of the values are less than or equal to 77. So X in this case was 77. Okay, so now we're just going to try a couple of problems using the correct notation. So now we're going to try a few, but this time we're going to add in correct notation. So Corey scored a 65. What this means is that X is 65. And to calculate the percentile, how we would write that is capital P, parenthesis, X less than or equal to 65 is equal to, and then I need to go back up to my dot plot. This is x equals 65. So I can just count up this and to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 scores out of 20 scores are less than or equal to Corey's score. This translates or calculates to a decimal of 0.60. So to interpret this, the value of 65 is at the 60th percentile. About 60% of the randomly selected students scored less than or equal to 65. So this part of the randomly selected students scored, that is your context. That is your context. Sorry, I'm just finding a marker. So we're not just making a generic statement. We're making our response specific to the problem. That means that we're adding context. Okay, next problem is Casey. Casey scored 43. So we would say x is equal to 43. To find the percentile for that score, we say capital P, parenthesis, x less than or equal to 43 equals the percent of scores less than or equal to 43. I can go up to my dot plot again and label this dot here is x is 43. So this time it's 1, 2, 3, 4. Only 4 students scored the same as Casey. So 4 out of 20 gives you a percent of 20%. So now we interpret. The value of 43 is at the 20th percentile. About 20% of the randomly selected students scored less than or equal to 43. So we're about to move on and do one all on our own, but before we move on, I want to highlight how a percentile can give us information about these observations. So on Samantha, her percentile tells us that she actually did really well on this exam. She's in the 90th percentile, which means that 90% of the students scored less than or equal to her. What you can alternatively say is Samantha did better than about 90% of the students. So the other way you can say this is Samantha did better than about 90% of the blah, blah, blah. I'm not going to finish writing that because I don't have room. I apologize. So we have to say about 90% because it's not exactly 90. because Samantha is included in that calculation of 90, and she didn't do better than herself. So we have to use the word about. So Samantha did awesome. Corey did pretty well. Corey did better than about 60% of the randomly selected students. But Casey, she's not doing so awesome. Casey only did better than about 20% of the students. So she's actually on the lower end. So the last problem that we have on this percentiles page is you calculating the percentile for Bridger. I have it covered up because I already have it done. I want you to pause the video and I want you to do Bridger, the problem for Bridger, all for yourself. So the calculating and the interpreting. So pause. Okay, so my answer is the value of 58 is at the 50th percentile. Uh-oh, I forgot to fill in a bunch of information. In this case, x is 58. You're finding p of x less than or equal to 58, which is 10 of the 20 observations. So the value of 58 is at the 50th percentile. About 50% of the randomly selected students scored less than or equal to 58 points. Oh, up here I didn't write points. I'm going to add that in. And then right at the very, very bottom, I have note that this is not the median. Remember, the median is the value for which 50% is below it and 50% is above it. The score of 58 is included in the 50% below. So including Bridger, 50% of the data is the score of 58 or less. So Bridger is in the bottom 50%. Also, you can see at the top that the median is calculated to be 59.6. That's because the median is in between Bridger's score at 58 and this score, oh, I was wondering why my reasoning wasn't working out. Sorry about that. The median is 58.5. And the reason why is because the median is right here. It's in between Bridger's score and the person that scored 59. So even though Bridger is the 50th percentile, that is not the median. Okay, so now we have a practice problem, two practice problems. The stem plot shows the number of wins for each of the 30 Major League Baseball teams in 2009. The Colorado Rockies won 92 games. Calculate their percentiles. So X is 92, and we need to find the percent of games, or the percent, sorry, of teams that won less than or equal to 92. So I'm going to identify 92 on this, or in this stem plot. So that's this value right here. They didn't give us a key, that's not awesome. So in this case, it might be easier to figure out how many teams scored more than 92 because there's a lot of teams that scored 92 or less. And this problem actually says what number of teams performed better than the Rockies? Well, 1, 2, 3, 4, 5. Okay, well, we know that N is 30. So if 5 scored better, that means that 25 out of 30 scored 92 or less. You guys could count them all up if you wanted to. I think this is a little quicker. If we plug that into our calculator, we get 0.83 repeating. So now we interpret. The value of 92 games won is at the 83rd percentile. About 83% of the teams won less than or equal to 92 games. So notice I added in a little bit of extra context here. I have the value of 92 games won. We didn't get anything wrong here by saying the value of 65. It may have been better for us to say the value of 65 points. It might have even been better to say the score of 43, the score of 58. There would be nothing wrong with that. That would just add more context. And context is always good. Okay, let's have you guys try number 2. Mark receives a score report detailing his performance on a statewide test. On the math section, Mark earned a raw score of 39, which placed him in the 68th percentile. This means that, so you guys can pause if you need to. Okay, hopefully you answered it because I'm about to tell you the answer. The answer to this one is C, as in Charlie. So if we have this line here that represents 100% of the data, so this would be 100% of the data, this would be 0% of the data. 50s here. So that means that Mark's here at 68% or the 68th percentile. So what that means is that this section below, I'm going to highlight that. That section below is all of the students that scored less than or equal to 68, which means that this section above is 32%. So Mark did not do better or worse than 39%. That was his score, not his percentile. His percentile was 68. Mark did better than about 68% of the students who took the test. It has to be C. He did worse than about 32% of the students. He did worse than 32%. Mark got fewer than half the questions correct on this test. There's no way for us to know that. That's not even an option. We don't know how many questions were on the test. Okay, so that is your basic understanding of percentiles. Where we're going to use percentiles the most is with the standard normal curve, but before we get there, let's relate percentiles to the standard, not the standard teacher, the normal curve. So Charlie is a member of a bowling team that competes in a league every week. From experience, it is known that Charlie's team scores are approximately normally distributed with a mean of 165 and a standard deviation of 15. So let's draw this curve. Let's draw the curve that matches N 165, 15. So in the middle, we have 165, then 180, 195, 210. Below, we have 150, 135, 120. My curve's not super awesome, but it'll do. Charlie typically bowls 180. What is his percentile? Okay, so X is 180. So we're going to go over here and we're going to mark that. And I want you to put a little flag on it because that's going to become really important in the next unit. So this flag is planted at X is 180. This is Charlie. Okay, well, if we want to find the percent of data that is less than or equal to a score of 180, we can use the normal curve to calculate, well, what percent is below 180? Well, we know from our cheat sheet that this is 34, 34, 13, 34, 34, 13.5, 2.35, and 0.15, or I at this point just have memorized that above the first standard deviation is 16%, which means that below is 84%. So you either add 34, 34, 13.5, 235, 0.15, or you do 100 minus 16. So that means that 84% is below Charlie's score. Less than or equal to Charlie's score. So Charlie is at the 84th percentile. Charlie's teammate bowls a 150. What is his percentile? So X is 150. So just like on the last one, I'm going to plant a flag. I'm going to label it. And then I can add up how much percent that is. Well, turns out if this is 16%, then that's 16%, or you add 13.5, 2.35, 0.15. So P of scores less than or equal to Charlie's teammate is 16%, which means that Charlie's teammate is the 16th percentile. So Charlie did better than about 84%. of his team, but Charlie's teammate, not so awesome. He only did better than 16%, so he's in the bottom. Okay, now we're going to try a few. Number 1, the distribution of number of hours worked by volunteers last year at a large hospital is approximately normally distributed with a mean 80 and a standard deviation of 7. Casey submitted the mean number of volunteer hours. What is her percentile? Okay, well, we draw up this normal curve. We know the mean is in the middle at 80, 87, 94, 101, 73, 66, 59. Well, Casey submitted 80. How do I know? Because it said Casey submitted the mean number of volunteer hours. So this is X is 180. Oh, just kidding, 80. Well, what percent do we know is below the mean? Well, this is 34, 13 and a half, 235, 0.15. So the percent of data that is less than or equal to 80 hours is 50%. There was a weird edit there, or because I ran out of space. So Casey is at the 50th percentile. So while I was deleting storage, I decided to write an interpretation for this problem. I would recommend you copy it down, but you don't have to. I just wanted to give you an idea about how you could interpret this. So one way is to say 80 volunteer hours is at the 50th percentile. You could also just say Casey is at the 50th percentile. About 50% of the volunteers worked less than or equal to Casey. Or you could say about 50% of the volunteers worked less than or equal to 80 hours. There's really no, there's no 100% right way as long as you're using the correct format. So you're saying the observation is at the percentile, and then you're including the percent. About 50% of the context is less than or equal to whatever. Just make sure that you have all of this. If you didn't have this top part, you couldn't just say Casey. You would have to say that you know the 80 volunteer hours, blah, blah, blah. Okay, the distribution of heights of 6-year-old girls is approximately normally distributed with a mean of 46 inches and a standard deviation of 2.7 inches. Brandy is 6 years old and her height is 0.96 standard deviations above the mean. Her friend Jane is also 6 years old and is at the 93rd percentile. Of the height distribution. At what percentile is Brandy's height, and how does her height compares to Jane's? Okay, so if we want to know the percentile for Brandy's height, we need to find Brandy's height. So usually not usually, when we have a z-score, the variables that are involved are z, x bar, x, and sigma. Well, in this case, x bar is mu and sigma is the actual, or standard deviation is the actual sigma. So they give us z, 0.96. They want us to find the height. X is Brandy's height. We know mu from the problem, it is 46. And we know sigma is 2.7. How do we know that? Because they gave us the normal curve with this information. So now we set up an equation. 0.96 is equal to Brandy's height subtract the mean divided by the standard deviation. Okay, to solve this, we multiply both sides by 2.7. That gives us 2.592 equals x minus 46. Now we add 46 to both sides, and we get that x is 48.592. Okay, so we have Brandy's height. How do we find her percentile? Well, in these two problems, I had to draw the normal curve and label it. So let's draw the normal curve. Remember, our parameters are 46 and 2.7. So our center value is 46, 48.7, 51.4, 54.1. I will let you guys fill in the lower end. Okay, well, where would Brandy fall on this normal curve? Brandy's height is 48.5, and luckily we have a standard deviation that is very close to that, which is 48.7. So we're going to put Brandy at that standard deviation because they're about the same. Well, I know that the upper part is 16%, which means that below Brandy is 84%. So Brandy's percentile is about the 84th percentile. So Brandy is about 84th percentile. I'm saying about because I'm not 100% sure, and in stats, when you don't know the exact value, you use the word about. Okay, well, Jane's the 93rd percentile, so that means that Jane is somewhere in this section. Jane is somewhere up in this section. I don't know quite where. I don't know at what exact value Jane's height would be, but Jane is somewhere in here. So Jane is in here. So Jane is higher than Brandy. So let's see what our options are. We think that she's at about the 84th percentile, so that means these first three options are a no. So we're going to choose Brandy's height is at the 83rd percentile, which would make sense because this is slightly less than 48.7. And she is taller than Jane, so it is E. She is not taller than Jane. Teacher, thank the heavens you used a pencil. Murphy, no, bud. She is shorter than Jane. D as in Delta. She is shorter than Jane. Because Jane's up here in the top 16%, and Brandy's over here at 83. Okay, one more problem. I would pause and try this one. I think that this is a really good critical thinking, problem solving skills problem. So I would pause and see if you can do this. And then when you come back, I'll explain my reasoning. Okay, they want us to order these values or these positions from least to greatest. All of these describe position. So the first one says R is the value in the data set that has a z-score of -1. Okay, well that means that if the distribution is normally distributed and the mean is in the center, a z-score of -1 is right here. A z-score means you are one standard deviation below the mean. So this z-score, z equals Murphy, -1, means 1 sigma below mu. Okay, well, if I add up the percent for that, so this is z equals -1. If I add up this percent, hopefully we're getting to the point where we're memorizing that's 16%. So -1 sigma, 1 sigma, 2 sigma, 3 sigma, -2 sigma, -3 sigma. You would add up the percents. So what that means is that this is the 16th percentile. Okay. S is the value of the first quartile, so that's another position. If I draw a rectangle to represent my entire data set, the median is right in the middle, the lowest is the min, the highest is the max, and then Q1, Q3. Well, this is 0% of your data. Quartile 1 is 25% of your data. 50% of your data, 75% of your data, 100% of your data. So it turns out that quartile 1 is at the 25th percentile. "25% of the observations are less than or equal to the first quartile." Then lastly, they just give us T is the 20th percentile. So if we wanted to order these least to greatest, the smallest one is R, which means C through E is out. Then the next one would be T, so that gives us the answer must be B. So they gave us the position of 3 of the observations and wanted us to order from least to greatest. We were able to do that by changing those positions to a percentile. So that is percentiles. The heart of the matter is that it is the percent of data values that are less than or equal to your given observation. We went through and practiced how to interpret. If you don't like to add context and stuff like that, then you'll just want to stick with this. If you struggle with adding context, just keep it generic. If you can't add context, just write the generic interpretation. So down here is interpretations with context. Here we had a couple of practice problems. Notice that you can calculate percentiles if you're given a stem plot, if you're given a dot plot, if you're given, those are it. You can calculate percentile with a stem plot and a dot plot or a normal curve. Okay, so what I am going to upload for your Can You Do is a review of Unit 2, our short unit with 4 lessons, standard deviation, z-score, normal distribution, percentiles. I'm going to upload a review for that. We will review in class and go from there. Both A day and B days have a calendar uploaded now in our modules. So make sure that you have our calendar because this calendar is going to take us all the way to Thanksgiving break. And notice right before the break, you guys have a comprehensive exam. That just means that you will be tested on all 3 of the units we've learned up to that point. Most of it will be on Unit 3 and only a little bit will be on Unit 1 and 2. Your Unit 2 exam for A days is on November 5th, and for B days, it is on November 4th. Lastly, remember that you guys have a quiz next class time. So whether you're a distance learner or an in-class learner, you are taking quiz 9. Okay, as usual, any questions, send them my way. Love you guys. Hope you have a great day or weekend whenever you're watching this.